Oops, let me go back. Okay, so we're going to have a whole bunch of vocabulary in this. I must have been having somebody observe me because I have all my little success criteria. We've talked a lot about the slope of the tangent line is the derivative. It's also any type of rate of change. So the instantaneous rate of change, f prime at a, the limit as h approaches 0 of f of x plus h minus f of a all over h. So you see this and go, oh God, not again. No, this just means you can use the shortcut anytime you want, unless it specifically says you have to use the definition. Now, notice that the word instantaneous is in parentheses. If the word instantaneous is left off, if we just say the rate of change, we always mean instantaneous. The only time we mean average, we say average. Average means the slope of 2 points. Every other time, we're finding the limit as h approaches 0 of f of a plus h minus f of a all over h by using the shortcut. Okay, so example 1, find the rate of change of the area of a circle. So what is the area of a circle formula? A equals pi r squared. So a prime, remember pi is a number, that's a coefficient, 2 times pi, subtract 1 from the exponent. This is my derivative of the area of a circle. So that's my rate of change of the area of a circle. Letter B just says evaluate when r is 5. A prime of 5 equals 2 pi times 5, which is 10 pi. A prime of 10, which is 20 pi. Letter C, if r is measured in inches and a is measured in square inches, what would be appropriate for dAdr? Now, notice I just wrote a prime each time. I could also write the derivative of a with respect to r. That's the same thing as a prime. Do you remember when I said there are times when this would be helpful or times this would be helpful? When we're doing units, you literally do the numerator divided by the denominator of units. Area, square inches, inches squared. R is measured in inches per inch. Now, units cannot be simplified like this. Your unit of measure is inches squared per inch. That's what your rate of change is labeled as. Look at the stars. This is probably the most important page in this chapter. You're going to learn the rules, but the words, the vocabulary tends to be tough. So position can either be S, or I'm going to also put in X. On the AP test, it always says X. In the book, a lot of times it says S. So it's either S or X. You need to be a little flexible. Displacement, the change in S, the change in your function. And this is going to be where if you were in class, it'll be easier. So I need to point this one out when we're back together again. Average, important, is the slope of 2 points, the change in our y value divided by our change in time. Now, notice the difference. Average velocity is the slope of 2 points. Instantaneous velocity is the derivative of s, the derivative of position. Speed, the absolute value of velocity. Now, I'm going to point out if velocity, if it's moving forward, it's positive. If it's moving backwards, it's negative. It's very much like speed, but velocity shows direction. A positive velocity means the motion is moving forward. A negative velocity means it's moving backwards or falling. Okay? Acceleration is the derivative of velocity or the second derivative of position. So remember when we were doing 4 derivatives earlier? I'm going to call this SVA. This is going to be your key to doing all your word problems. You take the derivative of S of position to get velocity. You take the derivative of velocity to get acceleration. Okay, so all of the work is done for you in example 2. It's just all spelled out. So it shows figure 3.24 shows the time to distance graph. So that means this is my distance on the y. Always pay attention to your axes. And time in t is along the x-axis. The slope of the secant line. The secant is your average velocity. Okay? Average velocity for the 3 seconds from 2 to 5 is about 100 feet per second or 68 miles per hour. The slope of the tangent. So see the difference between the secant line is 2 points. The tangent line is 1 point. Okay, at time 2. Notice how my slope at point 2 is less than my secant line, right? So it says at 2, it's approximately 57 feet per second or 39 miles per hour. As this line gets steeper and steeper, the car is speeding up and getting more and more instantaneous velocity. Okay, so reading a graph. A student walks around in front of a motion detector that records her velocity, that's up and down, at 1 second intervals for 36 seconds. She stores data in her graphing calculator and uses it to generate the time velocity graph shown. Describe her motion as a function of time by reading the velocity graph. So let's first of all recall what it means to be if velocity is positive or negative. So notice we're really paying attention to where it's positive. So for the first, notice that each one of these is going up by 4. If we divide the 36, oops, I just said 36. So you might want to label that so you can read it a little bit better. So see how there is a positive velocity for the first 14 seconds. What does that indicate? She is moving forward. Then it's negative from here to here. So for the next, there's a negative velocity for the next 12 seconds, which means she is moving backwards or to the left. Sometimes backwards or left. It makes more sense that she's moving left. Notice this is where the velocity is 0. So if it's not positive or negative, there is 0 velocity for 6 seconds. What does that mean if she's not moving forwards or backwards? She is standing still. So for anyone that has had physics, that's going to help you greatly. It doesn't mean you can't learn if you haven't, but it should make more sense if you have had physics. And then after she stands still, she moves forward for the rest of the trip. Okay, when is her speed a maximum? What does speed equal? The absolute value of velocity. I want to know the highest point. Now notice this is where my velocity is max. Notice this is my most negative velocity. But which one of these is more? I guess that's a little down more. Notice here at 20, if I do the absolute value, my speed is a max at x equals 20, because if I take the absolute value of this number, it will be more than the absolute value of this number. Okay, I'm going to star this one. You're going to see this particular question. You would see it on a quiz. You'll see it on a test. You're going to see this a lot moving forward. Okay, anytime they give you an S function, and I'm going to tell you right now, I did not give you nearly enough room. You're going to need every single little space possible. So maybe go on the far right in that open little area up here. We're going to find S, V, A. S is my position, where I'm at the moment. V is the velocity of the motion. So that's the derivative of this S function. What's the derivative of 160t? 160. What's the derivative of negative 16t squared? Negative 32t. A, what's the derivative? Each time I'm going to take the derivative, SVA. This is your key to solving everything in this problem. The derivative of my constant is 0. The derivative of negative 32t is negative 32, and in this case, feet per second per second. For those of you in physics, that should ring a bell. That's your acceleration due to gravity. All right, so let's first of all think about this. I'm just going to draw a little picture here. A dynamite blast propels a heavy rock straight up in the air, and it comes back down. We can find the height by this particular equation after t seconds. All right, so it says, how high does the rock go? So think about this picture. The height of the rock, it's going to be the highest when there's a 0 slope at the top. That's when the derivative is 0. That's velocity. When your velocity equals 0, that's when your rock is at the highest point, because that's your tangent line is flat. So what I'm going to do is set my velocity equation equal to 0 and solve for t. Add 32t, divide by 32, and I get t equals 5. Now we have to be careful. If we think about our graph, let me just put the graph over here. We always graph x in terms of time. This tells me I reach my peak when my time is 5. Is that the question though? No. It says how high does the rock go? How high is position? When t is 5, what is s? So I'm going to find s of 5. So when I plug 5 in for s, I get 400 feet. Okay. Now, letter B. What is the velocity and speed when the rock is 256 feet above the ground? What number is this representing? This is representing position, which is s. Okay, so what I'm going to do, this is A. For letter B, is when is my position equal to 256 feet? Okay. I now have a quadratic t squared, but this is, my t squared's negative over here, so I'm going to move everything over to the left side. And I now have a quadratic, so I'm going to set it equal to 0. There is a GCF of 16. I can now factor my quadratic. Factors of 16 that add to get 10, minus 2, minus 8. So this happens at time 2 and at time 8. So let's think about this. At time 2, it's at 256. And back at time 8, I'm also at 256. Remember, my peak here is 400. So the rock is being shot up in the air at 2 seconds. It's at 256. Crosses the peak, comes back over at 8 seconds. Now it says, what is the velocity and speed? I have my time, but now I have to find v of 2. So come back up to v, plug 2 in for v. I get 96 feet per second, which makes sense. This is going up, so it's positive. Then when I plug in 8, I get negative 96 feet per second, which that makes sense also because now I'm on my way down and it's the same velocity going up as it is going down. The negative shows direction. And speed. So speed is absolute value. So it's 96 feet per second, both on the way up and down. All right. What's the acceleration at any time? We've already found it. Negative 32 feet per second. When does the rock hit the ground? You can almost make sense of this. At 5, it's in the middle. So at 10, it's on the ground. In 2 more seconds here, I'm back at equilibrium. There's just many different things. We could also set S equal to 0. Then there's a GCF of 16t. Then I get 10 minus t. T equals 0, which is when I started. And t equals 10. Those are the points that my position is 0 and it's on the ground. But it hits the ground at time 10.